Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals involving the product of mod function and signum function, right? So here in fact the signum function is inside the cosine function, right? So here our integrand, it involves the absolute value function, that is mod of x, and the signum function, right? So this problem is a very easy problem, and this problem is very useful for the beginners. So let us start. Now here let us call this integral as I, right? Now see, here we'll quickly see the definition of signum function and mod function, and moreover we'll take the lower limit and the upper limit, right? So let us first describe or represent the limits on the real number line, right? So here we have minus pi by 2, and here we have pi by 2, right? And between minus pi by 2 and pi by 2 we can take 0, right? So the importance of representing the limits on the real number line is to divide this integral, or to split this integral as a sum of two integrals, right? So now see here, signum of x can be defined like this, right? Signum of x takes the value plus 1 whenever x is greater than 0, and signum of x takes the value 0 whenever x is equal to 0, and signum of x is negative 1 whenever x is less than 0, right? So from this picture we can easily see that when we go from minus pi by 2 to 0, here x is less than 0, and when we go from 0 to pi by 2, x is obviously greater than 0, right? Okay, now let us quickly see the definition of mod function. Now see, mod of x can be defined like this. Mod of x is positive x whenever x is greater than 0, or we can take equal to 0 here, and mod of x is negative x whenever x is less than 0, right? So when we have here x less than 0, we'll have mod of x is equal to minus x, and when x is greater than 0, we'll have mod x is equal to positive x, right? So now we can write this integral as minus pi by 2 to 0. Here we have mod x, cos of signum of x dx, and here we have 0 to pi by 2, and we have mod of x and cos of signum of x dx, right? So now let us take a look at these two integrals. Now see here, from minus pi by 2 to 0. So from minus pi by 2 to 0. Now see, this signum of x will take the value minus 1, because x is less than 0 here, right? So here x is less than 0. So we can now write minus pi by 2 to 0, and mod of x is equal to negative of x here, and we have cos of minus 1 dx, right? Because here when we go from minus pi by 2 to 0, all the x are less than 0. So for mod x we will have minus x, and for signum of x we will take minus 1, because x is less than 0. And similar is the case with this integral. So we have 0 to pi by 2 mod of x, because x is greater than 0 in this interval. So mod of x is positive x for all x greater than 0. So here we have mod x and cos of signum of x. Now see, here x is greater than 0, so we'll take x greater than 0. So signum of x is positive 1, right? So here we'll have plus 1 dx. So now from trigonometry we know that cos of minus theta is simply cos of theta. So here we have minus pi by 2 to 0, and we have this negative sign outside the integral. We have x cos 1 dx. Here we have 0 to pi by 2. Here we have x cos 1 dx, right? So now cos 1 is a constant, so we can now take it outside the integral. We have minus pi by 2 to 0 x dx. Here we have cos 1, integral from 0 to pi by 2 cos, here we'll have x dx, right? So now we can simply evaluate these two integrals. So we have minus cos of 1 here, and we have x square over 2 minus pi by 2 to 0. The limits are, and here we have cos of 1, and here we have uh, x square over 2, and limits are from 0 to pi by 2, right? So now we can simply substitute the limits. So we have minus cos 1 here, and here we have 0 minus, and when we take minus pi by 2 for x, then we'll have pi square over 4, and that 4 will be multiplied with this 2, so we have 8 here, right? And here we have cos 1, and similarly here we have pi square over 8 minus 0, right? So now minus and minus when multiplied together becomes plus, so we have pi square over 8 cos 1, and here also we have pi square over 8 cos 1, and these two are like terms, so we have 2 pi square over 8 cos of 1. So this is 2 4s are 8, so we have pi square over 4 cos of 1, right? So the value of this integral is pi square over 4 cos of 1.